Okay, can you hear me? I think it's time to start. Welcome everyone to my talk. I'm going to talk a bit. I'm going to talk a bit about what I think agentic engineering is, and a bit about how my journey has been over the last 18 months to get to where I am now. I'll look a bit of some of the shifts that we've seen in that time, and I'm also going to show a few demos, so it's just not me talking all the time. So a bit about me. So my name is Mats Austad. I'm a developer software engineer by education. Spent a lot of time working across the stack with architecture, and then I moved over to more management and product management for a while in a few startups. Worked in shipping for 10 years, trying to optimize and digitize a quite antiquated industry. But I always felt like I wanted to go back to building. I was in meetings and mostly speaking to people, but my passion is to build things. And with the emergence of coding agents and LLMs, it was a good opportunity to go back to my roots, so to say. I work for a small company called Oslo, so we are 4 people of senior people that have been around the block, built companies, done scale-ups, and seen a lot of problems. We work with helping companies getting started with AI, building AI products, and so on. And if you want to come and chat with us, we have a little section down in the expo area. So coding agents, all you need to do is install it, type a prompt, and magic happens, right? Well, yes, no, maybe, perhaps. But like everything with software development, the right answer is probably depends. That's what we love to say about everything. And I think the vibe word started us out as a very buzzy, oh, this is so cool. But now it's almost looked at something with a very negative connotation. And that's why I think we need, as software developers, needs to look at it more as agentic engineering or coding with agents. And there is still room for building things in the vibe way, but maybe that's things that you just use once, things that never hits production, something you want to solve, but you need to put something more around it in order to make it durable and safe. My journey with this started maybe late 2024. I was just finishing up my management consulting gig, and I saw that I wanted to, as I said, go back to my roots. So I started playing with Cursor, which was quite new at the time. It felt like a autocomplete plus. It was capable. It gave me some value, but it didn't really blow my mind. And then the first thing that I really hooked onto was Aider. You can call that kind of the grandfather of the coding agent CLI tools. It had a nice terminal tool. It had a architect mode so that you can actually work in different settings. And this was the first thing that really got me to think that this is something that will be huge. And then when Claude Code dropped in February 2025, I was really excited, and I downloaded it. I think the first day it came out, and that was when it really clicked for me. When I really saw that I could build something and get something valuable out of these tools. And I've been mainly using that for the last year and a half, but now I also use a couple of other tools. I use Codex, I use Pi, and of course Cursor and anti-gravity, and those tools are also viable now and good, but I tend to like to be in the terminal, so I'm using mainly those type of tools. And the tools have really leapt forward, and so is how we use them. We have seen the models get a lot better, the tools get a lot better, and we also have more ways of expanding and building around the tools to really get the process and the right value out of them. So I have listed up 6 things that I'm going to talk about. I've called them shifts, in lack of a better word. So when we started out, everything was about writing the perfect prompt. The next big thing after vibe coding that was a big buzzword was prompt engineering. Everyone was going to become a prompt engineer. Spent a lot of time outside of the coding agent and tried to make the perfect prompt using ChatGPT, using Claude in the browser, and find a way to make the best possible prompt that I put back into it. But that's something that I no longer do at all. Now I shape the plan together with the coding agent. One of the really big shifts there was when we got plan mode in Claude Code. When I spoke at the Claude Code meetup 6 months ago, I spent a lot of time just talking about I live in plan mode. That's where I do most of my work in Claude Code. And that's still the case, but now I have moved more over to using a plugin. So I use Superpowers, which is a really great plugin, which I really would advise everyone to test out. It gives you a very powerful workflow, brainstorming. It has human in the loop in between each of these steps. You can even get it to make a example for you that you can look at in the browser. If you're working with design, with front end, it gives you different examples. So you can choose, okay, I like A better than B, and so on. And then you iterate together with it. It's kind of like when you're working with a person on your team. You build the context together. You're not just feeding the context into the tool, but you use the tool to build the context together and to make an understanding of what the outcome should be, so that you get better value out of it and have more control over what it actually builds when it starts making code. And I like to say that iteration got cheap. It's very easy to iterate now. I can build a proof of concept or an MVP that I used 2-3 weeks to do a few years ago, but now I can do it in 30 minutes, in 2 hours, in half a day. But you still need to work on the direction, on the goals. They are equally as important or even more important to know where you want to be, to know what gives the user the value. It kind of mixing the product management and the developer together. The roles are more interchangeable. You are no longer just the one punching in the code, but you're also working a lot more on that part of the process. And the next shift, as I like to call it, is that you should always try to use a script or a tool if that's something that can be used. Don't spend a lot of time on inference that you don't need to use on inference, because that's the expensive operation, the tokens. It takes a lot more time to do it. So I will give you a few examples in a little while soon that shows how this works and why it's important to always try to solve deterministic things in a deterministic way. Don't use inference to solve things that have already been solved deterministically. So then we're on to our first demo. I have made some simple demos. I'm not there. They are quite fast, because I'm sure you don't want to sit there and see that the agent is scrolling out text. So then we will jump over to our CLI. I have also been lazy and scripted this, because when one person look at me typing, I type very poorly, and when 150 people look at me typing, I probably type even worse. So I have just made a simple file that has IDs, it has names, emails, a role, if it's an active user, and how much money they have spent. So this is just a simple JSON file. And then for most of the demos, I will actually use the Pi agent. It's a very lightweight agent, and it's quite easy to control that harness. So it's easy to set up fast demos. And for the cloud version of the inference, I will use Sonnet. So it's a bit faster than using Opus. And even though we got Fable yesterday, I have tried not to look at it because then I might have had to change my entire presentation. So a bit more on that later. So I will start this. It will then kick off Pi. This one has the prompt list every email in scenarios data users. And as you can see, this does not use any tool. It just goes in and picks them out and write them out into the terminal. So it takes quite a lot of time, and it also uses more tokens than what you should use for such a simple operation. So that took about 20-ish seconds, and it found all 150 emails. It also told us that there is a duplicate. But if I then go out again and I kick off the second one, so this will now use JQ, which is a very nice terminal tool to work with JSON. And as you can see, it found all the emails, and it was substantially faster and used substantially less tokens. Of course, this is a very simple example, but if you think of this as a big flow where you have a lot of different tasks that you need to do, the tokens will really compound. So it's always smart to look at how you can move things away from inference and use, in this instance, a CLI tool. And the other demo on this file is even more telling. So then I will first use JQ. So this will add up all the cost that has been spent in this by all the people in this file. So that takes a few seconds, and it gives me that it have used $356,000 or so. And actually, if we quickly go back to the slides, so in my example here, you can actually see that in the other version, it gives us the wrong number. And that's also something that happens from time to time. So let us now see what happens when I run that in today. Will it give me the right number, or will it give me the wrong number? And just to be clear, I have also told it now to not use tools, because these new models and these harnesses are also very good at just using tools because they need to use tools, but now I'm forcing it just to make an example. So now it's going in, finding all the spent cents. And then it adds them together. And I actually got the right answer. But every time I have run this example, it does it in a bit different way, because yesterday when I ran through and tested and saw how long time I was using it, this took 3 times as long, and it actually went through them 10 by 10 and adding those 10 together and then adding the 15 10 by 10s together. So that also shows that inference is not deterministic. Always use deterministic tools to solve deterministic problems if they are easily available. Just cleaning up before the next demo, and then moving on. So this was an example of using CLI tools, and that's usually what I always reach for first. There are already a lot of problems that have been solved by simple CLI tools. Most of them are also built on the on the Unix way of thinking. You have one simple thing that solves one problem, so you don't have too much noise around it. I also like to combine them with a skill. If it's a CLI tool that has a lot of functionality and I just want to use 2 or 3 of those functions, making a skill that makes it faster is always nice. For instance, I use Coolify for some local deployment. It's kind of a local version of Vercel. And if I don't have a skill on that, it will always ask Coolify help, how do I use this CLI first, and spend tokens on that, instead of just using the things that I actually need, like deployment or something like that. And of course, MCPs, I still use them, but substantially less than I did before. They used to be the ubiquitous, this solves everything problem when it came out. And of course, the tools have also become better at not putting everything in the context, so it's cheaper to use them, but they are still a lot more complex and takes more tokens in almost all cases than using a CLI. I think a good example to test that is the GitHub CLI and GitHub MCP. It's a lot more efficient if you use the GH CLI than using the GitHub MCP. But where I see MCPs having a more prominent place is more in the office work, in using it in co-work, using it in Gemini Enterprise. But for development, I always reach for a CLI first. And the next one is kind of how I build my working process. So skills are the bread and butter in this. Before, I used to do a lot of building my own sub-agent, setting up more workflows, but this has become more and more part of the tools. But skills are really what is a simple way to take something that you do often and make it reproducible. You can use it in many different ways, and you also have a lot of good tools, like in Claude Code, you have a skill builder, it has evaluation, and it's very easy to build a skill. Just ask your coding agent to help you build a skill when you have a problem that you keep running into. So then we're on to the second demo. And here I will show a bit about the difference of having a skill and not having a skill. So this is a simple problem where we have a test that fails, and we want it to be fixed. So I have then what I've called the naive approach. So this will kickstart Pi with a prompt, but it will have the -ns no skill added to it. So this will then go through and see what files it has. It will look at the tests, and it will see that we have a rounding problem. The tests don't run green, and it fixes that. So no problem. This looks good, right? But in this case, we have a policy on how we round. So we are using bankers rounding. So we round to the half to the nearest even number. This was just something for to make it a decent demo. And also the minimum charge will always be a full amount and no decimals. So if we then run it in a skilled mode. So now it's the same prompt, and we can see that it now has pricing policy, research, systematic debugging. That's the 3 skills I have put into this demo account. And actually first it's, okay, this is a bug, so I will use my systematic debugging skill. And just like to point back, that skill is actually stolen from the the superpowers. So I have moved that over to Pi as well. And then it goes through, and it also sees, okay, I need to use the skill pricing policy to solve this. And now you can see it makes a completely different fix to the rounding. It checks me, gives me a bug report, a lot more information because I use the systematic debugging skill. And we see that it solved both test cases. Then moving directly into the next demo. So this is a skill, maybe the skill I use the most myself. So I have made a research skill that I have in my knowledge base repository. So every time I find a GitHub repo, a blog post, a YouTube video that I think is interesting and I want to capture the information from, I run this. So it will go and pull data from those sources, uses the YTDLP YouTube downloader CLI, and then if we move back here, we can show that. So here I'm asking it to research and evaluate a URL. So this is just one of the latest blog posts from Simon Willison about how Uber is capping their usage. So it will go and pull that down and create a verdict file. It's not done yet. So that file gives us key facts, what it is, why it matters, how I can use it, apply it in my stuff, and also a verdict. And when I use this in my knowledge base, it will also connect it to other parts of the corpus. So we can see, okay, we have a similar blog post here. This is about this topic, and collate and build knowledge about that. And we'll also see that, okay, this can be something that you can adopt in this project, or you are starting to work with this customer. This could be an idea to use in that project. So it's really a nice way to store your knowledge and to make sure that you capture the key points. And this is I'm using this kind of similar to if you have read the Karpati memory/brain method using Obsidian. So this is built in a similar way. I also sometimes use it the other way around. If I see a 1.5 hour YouTube video that might be interesting, I do this first, and then if the verdict is okay, then I put my time into watching it. Another thing that has been a topic lately is Markdown versus HTML, and what is the easiest way to actually read what is produced by the agent. And I was a bit unsure in the start, but I'm now also in camp HTML. It's a lot easier to actually commit to reading the output when you have something that is visually nice to look at. So I have made an example there as well. So this has been pre-made, but I have a concept markdown file. It looks like this. So it's an agentic loop, a goal in, gates on the way out. we have a flow chart, quite simple to read here, but also not the most pleasing to read, and quite a lot of text. I did have one thing that I did to make it easier for me before I made HTML, is that I had a plugin in NeoVim that actually makes an HTML file out of the Markdown. It's a step forward, but it's a lot easier to work with this. So this is the HTML version of the same file. You can see we have a lot better way of looking at the flow. You can interact with it. You can also I would also make a skill out of this. So I will make a skill that would tell me how this should be presented, how this should be, if I want any feedback mechanism and so on. And this is also a lot easier to share with other people that is not in the context that you have been building with the agent. And one tip here is to also look at the Playground plugin from Anthropic. It's part of the official Anthropic plugin library that gives you the opportunity to have controls, live previews, and you can also copy out the prompt. Actually, I have made my own version of that we use in our slide deck builder at Oslo. So here I can actually then give feedback to say that this slide has too much text, and I can go back to the previous one and say nice something. And then when I want to go back and iterate, I just do copy all, and it's connected to the context of the slide it's from, instead of me going back and forth. And this is also something that you can think about if you have a website and you want feedback from users. You can also set it up so that you can get the same type of contextual feedback that you just then can copy directly into your agent session. And one thing with skills, and not just skills, but everything that you can do to make the tool better, is if you see a mistake, if you do something 2 times, make a skill, make a hook, update the memory, update Claude MD or Agents MD, dependent on what you use. I also think that here you also need to separate between what is your workflow and what is the team's workflow. So you need to put it in the right context there. Often the memory in, for instance, Claude Code is just for you. Some teams have built their own shared team memory solutions. And I also think that one of the things that I like with these ways of working is that you can have your process and your way of working, but then put that into the team way of working. You're not that stuck into always working like everyone else as you were before. The next shift is scaling. In the start, I think most people were just working with one agent, one at a time. But what's really become easier now is to actually have many agents, both on the same project, but also having them across projects. So I use a lot of this. Use Git work trees to separate it, make sure that each session has a fresh context, have a structured way of doing handover artifacts, either it's Markdown files or HTML files, using the issue tracker and so on, and then making sure that we don't have too many merge conflicts that way. And there's a lot of tools that come out for this. You have like CMAX, you have Conductor, so there's a lot of ways you can do this, but I also see that the agentic tools will get more and more of this inside of it. So for me, for my workflow, I just use Tmux. Usually have that set up, one session for each project, and then I have panes and windows there that I switch between. And if one project is just working full load across that, I might switch to another project and kick off some stuff there. So you can really increase your bandwidth by going from one agent to many agents. And then I think maybe the most important step you can do in order to make the quality of what the agents create is to verify and do evaluations. I think this is where many of the vibe projects don't go. You need to have a way for the agent to verify itself. It needs to be automated. You do tests, type checks, validations, and so on. And this should be also as deterministic as possible. Don't spend a lot of inference on doing this. I have some cases I do it, but mainly I do this the old-fashioned way with tests and so on. One way I actually use a lot of checking between models is in the planning stage. So going back to the superpowers I talked about earlier, it does a brainstorming first. Then I usually take that document and ask Codex, hey, does this look okay? Do you have any input here? Question? So the question is, where do we put the plan files? Yeah. Yeah. So I usually have the plan files in the same Git repo, but most times I actually take the plan files and split them up and make issues, for instance, on GitHub or whatever issue tracker you use, because often my plans are quite big, and I don't want to do that in one bite. So then I instead of going into the building phase of superpowers, I ask it first to split it up and make a GitHub. Yeah. Yeah. So I usually also keep it as files in the repo, but I think if you're a bigger organization, maybe if you use a documentation platform, I would probably then use an MCP or something like that and put it there to make sure that at least the long-living documentation is easily available there. But for plans, once I have finished the plans, I will take what is valuable in the long term out of them, and I will delete the plan because it's no longer valid. So yeah, I will then use Codex to verify Claude's work. Usually do that dance back and forth a couple of times. It also works quite well to use Claude to verify Claude. You just open a clean context and do the same. But I do feel that I get a more nuanced feedback if I use two different models. So that's a nice tip to make sure that you find these little errors in the plans before you do the human in the loop review. And another thing that is also important here is security. So that was what was the topic of the keynote, and I think that is probably what I spend most of my time human in the looping, because that's something I do not want to have leakage. It's fine to have a bug or two, but if you start leaking customer data or something like that, then you have lost all confidence from every user. So that's where I at least now spend a lot of my human in the looping. And then Mythos/Fable has said that it's very good at security stuff, so maybe that's not the case anymore after that release yesterday. And I think it's also important to watch what the model did and not what it told you in the chat, because that might not always be the same thing. So it's more important to have ways for it to verify what it did than for you to verify what it said. And the next big shift, and this is what's been the most recent one, is that now the models and the tools are a lot better at working on its own for a longer time. So this is an example I have from the new dynamic workflow that came in Cloud Code 3 weeks ago, I think. So this is a quite big part of an application I'm working on. It's a full feature database. It has APIs, a full front end. It uses a model to verify and check if the data we are getting in actually is of the quality we want. And here I ran a full superpowers on it. So it first did the design. As you can see, it used 11 agents. So it built its own sub-agents fit for purpose, about 1 million tokens, and it worked for 21 minutes without me having to answer anything. Then I had a short human in the loop step before it went on to plan, and it's a bit shorter, but still used almost 700,000 tokens. And now it's in the middle of building. So this was maybe 60% through that step, and it ended up using about 2 million tokens and running for 1 hour 45 there. So then I had a full end-to-end feature in my application. In the workflow, I had 2 steps. I had to just say, move on to plan, move on to build. And all the tests and all the verifications ran green. There was one little bug I found when I was testing myself. Just a small front-end issue, not showing showing some text. But this is a good example of how powerful these ways of working are now, and that a lot more can be done away from keyboard. The only thing to mention here is that it's quite token heavy, so it's not the cheapest thing to do. My colleague actually used up his full 20x subscription in a couple of days for the week by running these quite heavily. Another thing that we also see have been coming both in Cloud Code, in Codex, is the goal keyword. So this is where you tell it to keep on working until it has reached a goal. And this is similar to the Ralph Wiggum loop that had a lot of buzz a while back, but it's a lot easier to work with and a lot smoother. So I do a quick example of that as well. Oops. So this time I will use Cloud Code. So it tells it to make the tests in scenario goal pass and then implement the 2 CSV per its contract. So this is a quite simple example, so it will most likely solve this in a loop, but this can be set up to do a lot of work. And it's less token heavy than the workflow example. Let's also put it in auto mode. So now it's found a problem. It's a quite easy function to add. It runs the test, goals are met. It shows me what it implemented, and you can see it only used 1 turn and 1.7k tokens, but of course this can be a lot more complex goals that you solve like this. So this is something I built that we use on our internal products. So I've set up what I call a sentinel on our dev box that we run local models on. And I've put that sentinel to listen to signals from logs, from our CI, if issues have the right tag in our issue system, and so on. And then it will pick that up. It runs every 5 minutes, and then it will use our pre-warmed container. So it uses Incus containers, which is really lightweight. Spins up in a second or two, and then it will start to triage. So if it finds a bug in the log, it will look at that and see, okay, is this a complex problem? If yes, it will send it down to Claude Code. If it's a simple problem, it will continue using our local model and solve it like that. It then will create a pull request, shut down the container. The pull request will be automatically set to be reviewed by Codex. And then once the next run of Sentinel starts, it will then pick up the pull request and see, did we get any feedback? And then it will go like that until you're happy, and then someone from the team can look at it the next morning and see if it's something worth merging. From the test I've been running, I would say it's about 70-30 on what goes into the local model and what goes into the Claude model. And since this is running completely without any connection with a person, it doesn't matter if the local model is a bit slow. If it takes 2 hours or 10 minutes, it doesn't really matter because this just happens on a server. And the container is sandboxed, so it can't really do much damage either. This is also connected to our Slack channel, so we can also go in there and tell, hey Sentinel, I made a new issue, can you please look at it? Or I have an ID, or I have looked at PR26, you can merge it now. So it's a fully connected system. And I think this is something that we will see more and more of. This was quite easy as well. It's just really a collection of bash scripts that are set up to run on the server. So to recap a bit before we start looking at what I think will happen in the future. I think we need to look at the model and the harness together. They are both important. We still have a lot, I think at least, to do to improve the harness to get the value out of the models we have today. As I said, I haven't yet tested Fable, so I don't know how much that changes the needle there, but I think we can do a lot more on top of both the frontier models we have now and also the local models to get proper value out of them. It's not always waiting for the next model. You can improve how you use the models you have today. We want to push as much work as possible out of the models. Deterministic stuff should be done deterministically. If you see a mistake in the agent, do something more than once, make a skill, make a hook, automate it, and use the agent itself to automate how it can be better. And finally, use different models, check the work of one model with another. I also think it's smart not to get too stuck into one world. We don't really know who is going to win or who will be best in 2 months. So it's kind of like to compare it a bit about how the JavaScript world was 10, 12 years ago. You had a new framework, a new library every day, and suddenly, oh, I chose this React state tool, and then 3 days later, no, this is a lot better. We will not keep on working with this. So I think you need to be flexible, and you need to be willing to test out different ways of working and different models and different harnesses. So where are we going? So I'm no fortune teller, but I'll say my opinion, and maybe most of you will disagree, but that's fine. I think we are now at the state where we are in between two places. We've been used to writing code for other people or for ourselves to pick up, to evolve, to fix bugs, and so on. And today, and for the last year, I would say that we are in a state where we have people writing code, we have agents writing code, 4 people and 4 agents. But I do believe with the power we already have today that most code will be written by agents for agents. And I already think we more or less are there, especially with greenfield development. For more complex, large old code bases, it's a bit of a way to go, but I think we will get there. And I also think that that has a lot to do with how you build the right context for the agents to work in those code bases. It's a lot easier to do that if you start fresh. So I have written 2027 question mark here. Maybe that's correct, maybe not, we will see. And but I do think that this will change how the job of a software developer is and what it will be. One thing that might put a bit of a break on this and make it go a bit more into the future is that cost is going up. So this is a couple of examples from the news the last 2 weeks. After Copilot changed their pricing model, the Norwegian welfare agency said that their cost went 3 to 4 times up overnight, which is a quite big sum for such a big organization. And also looking back at the research we did earlier in the talk, Uber has capped their usage per person at $1,500 per month. That's still a big sum, but that shows that they were using quite a lot of money as well. So I'm still living in that world where I have the Claude Code 20X that I can use hard, but for people on enterprise and the team accounts, the number of tokens that you can use are a lot lower, and the cost will rise. And we also saw that with the release of Fable last night, that they will give it as part of the subscriptions now for 2 weeks, and then they will move it to API only, at least for a while, and then we will see how that will be in the future. And with this change in cost, we also need to start thinking a bit differently. Now at least I am using the top model for everything. I just use Opus for everything until it's empty, but that's quite hard to do on the 20X subscription. But I think we need to be even more picky about what we move off inference. Don't just use the inference because it's easy and you have it open. Looking more at picking different models, smaller models for simple tasks, and also looking at running local models. So I'm going to show one example now. We have Gemma 426B running on our server. I think I forgot to warm it up before I started. It needs to be put into the VRAM. Okay, so now it's warm. So then we can kick it off. So this again uses Pi, but I'm telling it to use the Gemma 4 model, and it's asked to implement scenarios parity slug.ts and make its test pass. So we can see just like the other using Sonnet earlier, it looks at the files, it sees there are some tests to run, they run red, it fixes it, tests run green, and we're done. So this is a model that can run on quite, you don't need a NVIDIA card to run this model. And there's also actually a slightly smaller version that came last week, I think, that can run on most developer laptops. It's quite close in quality to this one. So this went quite fast. If I reset, we can also see the same process with Sonnet, just to give you a comparison. So same prompt. It solves it in the same way. It's maybe a few seconds faster, but not that much. And of course, this was a very simple example, but we are starting to get a lot of local models that can do a lot of these type of things that maybe before you could use Haiku or even Sonnet to do to save from the state-of-the-art model. And I think the thought that a software engineer is going away, I don't believe that. Generation of code has become easy, not free, but easy. But we still need humans to think. We still need humans to understand the problem. We still need humans to understand the outcome. And maybe most importantly of all, we still need a human to be accountable. We can't just say, oh, the agent did that. It's not my problem. No, it's your problem. You directed it to do it. So we will still need software developers, and I still think that most code will be built by software developers using AI agents, just that our job will be different. We will be more conductors or orchestrators. And I also think that teams will become smaller and roles will be a lot more fluent than what they are today. There's a few more things that might be worth looking at. So I talked about superpowers. Skills.hsh is also a nice place to get inspiration. I tend to not download too many skills directly. I tend to more use them to see, oh, this was a cool way of thinking. And then I take that and then I build my own using the agents to tell it, use this as an example, but make it fit into our workflow. Because you don't really want to just start downloading things willy-nilly, just like with everything else. I think it's about 800,000 skills there now, so it's really growing. Another thing that I use quite a lot is the official OWASP Secure Agent Playbook. So this is a set of skills that actually runs on your code base and checks it against the OWASP top 10 security vulnerabilities. So I really would say that everyone should download and test that, because it usually finds something, so it's worth fixing. The Pi coding agent is also a very nice way to look at it from a bit different way. It's very extendable. You can make your own extensions. One thing to note is that it's YOLO mode by default, so don't So put in some guardrails. I also use the agent browser CLI a lot, so I use that to check my front-end design. It takes screenshots, it compares, it verifies using that. A similar one is the Playwright CLI, so they are quite similar. So now I have stopped writing all the code myself. I think maybe I'm at close to 100% code being written by a coding agent now, and I shape the work that happens instead. So that was my talk. So thank you. I think we should have time for some questions. Any questions?
Can you share your research skill?
Yes, I can give it to you, but yeah, it's quite simple, but yeah, I can share it.
You said you could run like local models on laptop, like you don't need any GPU at all?
Sorry, I can't hear.
What kind of hardware do you need for running a local model?
So I think you can run the smaller JAMA model quite okay on if you have 64 or even 32 gig RAM. So this model I ran now, we have it on a Strix Halo machine that has 128 gig RAM and 96 of it is VRAM. But I think some of these models are getting quite fast to run on what I would call a normal developer machine. Okay, no more questions. Thank you everyone for listening.